Let's take a look at arithmetic sequences. In these problems, we're going to be taking a look at determining whether our sequence is arithmetic. And right now, we're going to take a look at the sequence 2, 5, 8, 11, and that pattern would be continuing. Arithmetic sequences can be defined recursively, so let's take a look at identifying our first term. Our A1 value would be defined as the first term in our sequence. So the sequence we're looking at, our first term is going to be the number 2. In arithmetic sequences, we're going to be looking for what's called a common difference. The common difference is going to be noted by the letter D. And in order to get that, we're going to be subtracting two of our terms. I'm going to list them here as a sub n minus a sub n minus 1. And it doesn't matter what set of terms you use to subtract to get that common difference. If I look at my first two terms here, if I subtract 5 minus 2, I'm going to get 3. And if I subtract 8 minus 5, I'll also get 3. So my common difference in this example is going to be 3. So I went ahead and used my a sub 2 minus my a sub 1 value to get my common difference in this example. So I'll go ahead and use 3 as that common difference. So anytime you're working with arithmetic sequences, they should always be following some type of pattern. And one way to write this pattern would be, we have our a sub 1 value, and our next term would be a sub 1 plus that common difference, so plus d. My third term here could be a sub 1 plus 2 times d, and this pattern obviously could continue with our sequence. So let's go ahead and take a look at our next example. We want to show that the following sequence is arithmetic, which means we want to go ahead and find our first term, and we want to be able to identify the common difference. We're going to be using the sequence s sub n equals 5n plus 8. Let's go ahead and find our first term. So we're going to be looking for s sub 1. We're going to go ahead and plug in the 1 each time we see an n. So the first term in this example is going to give us 5 times 1 plus 8, which is going to be a 13. Let's go ahead and find the n minus 1 term. So we can go ahead and plug in n minus 1 every time we see one of those n values, and let's go ahead and simplify this piece that we have. So after we distribute that 5 to both pieces inside our parentheses, we're going to end up with 5n plus 3 as the n minus 1 term. Let's go ahead and find our nth term. So our nth term would be the same thing as just plugging in n, so we're going to get 5n plus 8. Now, let's go ahead and find the common difference. To get our common difference, we're going to go ahead and subtract our s sub n minus s sub n minus 1. S sub n was 5n plus 8, and s sub n minus 1 was 5n plus 3, and we're going to be subtracting these two pieces. So remember, you're going to have to distribute that negative to both pieces in that set of parentheses. Our common difference in this example is going to come out to be a 5. The difference of any two successive terms is going to be the constant 5. So our sequence S sub n is arithmetic with that common difference of